Welcome back, everyone, and today is going to be the first video about building our ECS framework. And this is going to be built into Fungi. It's going to kind of replace a lot of our renderables and our rendering system, and how we add code for each item that runs it. Overall, a lot of systems, this is kind of something that's been around for a long time, and it's getting more and more publicity, especially since Unity is now going to switch over to this system. Right now they're previewing their next version, which uses the ECS framework, but it's really just a set of ideas. So it's going to do a quick primer of what it is and some things about it, and then we're going to start building the first few pieces of our system. So what is ECS? And ECS stands for Entities, Components, and Systems, and not to be confused with Entities and Component Systems. Yeah, it's weird, but yeah, it's the same thing for two different meanings. So ECS, let's say the new ECS is a lot more different and a lot better. So what it is essentially it's a design pattern all about separating data from logic. This design pattern works very well for anything that has a lot of data that needs to process that data in kind of like a linear kind of way. And so not all applications should really use it. Like game programming, game engines, definitely. That's why it's becoming very popular in game engines. It's because when we're building a scene, we're building everything linearly. We're rendering one item at a time, and everything's very linear. And we have a lot of data. We have a lot of game objects you have to go through, process it, and things like that. Maybe a web server. A web server, very linear, has data that comes in one at a time. So things like that, something linear, something just this, it kind of has like this loop that just keeps on going. That's what ECS is really good for. The way you write it, the way the design pattern, kind of the mindset around it is that it's very functional programming. The whole idea is to actually avoid using classes and inheritance. So before we would create a transform, and then our renderable would inherit our transform, and then we will build our line or our point tool, which would then extend or inherit our renderable, and you end up having this huge kind of hierarchy of inheritance, and that makes things more complicated, harder to manage. It's like the bigger the hierarchy of inheritance, the more trouble you're going to have down the line. And me being a single developer managing a project, it's not too bad. But when you start having a team of people and people just start making inheritance, it becomes an issue. So this kind of avoids all that. It's basically saying we're not going to inherit anything. We're going to build things in pieces. One of the biggest reasons for a lot of systems, especially Unity, and to really move to the ECS design pattern, is because if you do it correctly, you can improve your performance by using the CPU cache. If you're here coming in as a JavaScript programmer, you're like, what the hell? What are you talking about CPU cache? Long story short, ECS is really meant for like C++ or Java or C#, because you can have more control over your memory, and everything is a type system. Especially with C++, you have so much control over how memory is used. And the basic idea is that you create a struct, which doesn't exist in JavaScript, hence why it's not possible in JavaScript. Sad face. Basically, a struct is just this lump of memory, kind of like an array, right? And then you can create an array of these structs, which makes this one big, huge lump of memory. And it's actually one big lump of continuous memory, as opposed to what in JavaScript, we create an array, which is a lump of memory, but each element of the array is a pointer. So that's not very good, because that means even though we can process it linearly and it is a chunk of memory, every single element is a pointer. So that means if you're in element 0, you got to go somewhere else in RAM to get its actual value. If you're in element 2, you have to go somewhere else in RAM to get the actual value. If you're using structs like in C++ and make an array out of them, when you're at element 1, that's where it is in memory. And when you go to element 2, it's right next to it in memory. Then element 3, next to it in memory. So if you have all this data as one big lump section of memory, that kind of stuff can be thrown into something called the CPU cache for processing. And the CPU cache is super much faster than RAM, random access memory. So the way, so basically you build your data structures in such a way that you can capitalize on certain features of how the hardware works, and that's one of the reasons why Unity is going for, because you do get that performance boost. Like where if your system can only handle like 100 characters on screen at a time, you can probably handle maybe 200, 300, or 400 characters by using the CPU cache. I'm probably over exaggerating, but overall you can improve. Now I'm wasting too much talking about because we can't do it in JavaScript. So why is, if that's one of the biggest reasons to do it, why are we going to bother? Because this system, and my next point is, it makes things super flexible. Very, very flexible. We're going to get rid of hierarchy, and we're basically going to turn all our code into chunks of Lego blocks that we can reassemble and build anything we want. And we can do this at runtime. And that's like one of the more beautiful aspects of ECS, is that we can build things at runtime. Where if we're using inheritance, everything is hard coded. So if I make a ship and it's inherited from resources, from renderable, which is extended from transform, it's stuck that way. If I want to, I have to kind of go back and add another inheritance or add to that class to add more features to it. This we don't have to. Well, with this kind of system, you could probably build a bunch of different like building blocks and then swap them around. So I can have, let's say, an entity is a collection of components, and components is just data. That's all it is. A component is just data. It's just a struct. And systems is the logic that actually gets processed on those components, on that data. And that's how the system works. So you have a bunch of data that's applied to a specific entity, or for us it was a renderable, or in Unity it's a game object, and you just throw it to a system and it just processes it all linearly in one way. And it just moves on to the next system, and that system processes entities of specific components. Right now you might be like, my final part, this might be hard to wrap around your head a little bit, especially since it's functional programming. I like functional programming. I don't use it as I kind of go back and forth between object-oriented and functional. I never believe in focusing on one design or one programming style, because I think if you focus too hard on one programming style, you sometimes have to do this weird long way around to do things on certain things, whether it be just easier. Like functional programming is good in a lot of ways, but sometimes you might need to learn inheritance, because the inheritance would actually make your code smaller and a little bit easier to manage, or vice versa. So we're not going to build something what's called a pure ECS system. We're going to build a hybrid. So we're going to try to be as ECS as possible. We're going to try to be as functional as possible. But if it's just easier to use object-oriented and just keep it to a minimum, everything is okay. It's perfectly fine. And like I said, since we're using JavaScript and we can't actually get some of that data performance out of it, then there's no reason to be strictly pure. There's no reason for that. So now I'm done rendering, battling on. Let's look at some code and get some idea of when we're going to start building the system. So I have a file called ECS, and that's going to have a lot of our code. And the first part we're going to do is build the components. And like I said, a component is just data, right? And the component is actually just a single function. That's all it really is. It's just the way I built it is just a single function. The way you do it with other people can build it differently, but in my way, I built it as a single function. And since JavaScript does not allow me to have multiple, what's the term? Overloads for functions. So like I want to have a component, I want to pass in a string, or I want to pass in an array, but I want the code to be different, but I want the same function name. Can't do that in JavaScript. We don't have that kind of ability. So I kind of ham jammed it, or kind of just hacked it into my component's function. So I check what type it is. So if I pass in com and I see the type is a function, I know you're either passing in a function or you're passing in a class. So that means you're going to register a component. So that's what this. So that when you pass it in, you're registering a component. And when you register a component, it goes and checks to see on the list if one exists. If it exists, it tells you, hey, you can't add this component. The one array exists. If this component is brand new, we're gonna get we want to generate an ID number for it, like a specific type ID. So this have like a number representation of the text name of it, just in case I want to serialize it. Now, I'm using a function called hash code, and I found like a very simple hash algorithm to generate IDs. I've seen some systems where they kind of use just random numbers or they use incremented numbers. Now, there's one problem for I see systems that do it that way. Especially in the world of JavaScript, if I were to change the order, like especially you can't use random, because that means if I want to serialize the data and then and deserialize it, random can't work. And then if you have the order only works if you make sure that all your components load in at the exact same order. That might be easier to do in like a language like C++ and C#, but that's definitely not going to work very well in JavaScript. You might change things, and it might actually have a component load in before another component. So I'm going to use a hash code. So basically, it takes the name, it hashes it, it generates a numeric value that represents that name. Now, the only problem with using a hash for an ID number is that you're going to run the risk of collision. That means the exact same name, the two different names generate the exact same number. I'm not going to have a whole list of components, so I'm not too worried about collision. But if somehow a collision does happen, I'll probably just go find another hash algorithm, test it, and if it generates better integers, also be it. Or I might just do something that generates a huge unique identifier with those big long letters and numbers type of thing. So this way, there's very little chance of collision. So I'm starting small, and if it becomes a problem, I can really change it, and it won't be that much big of a deal, really, in all honesty. So once I generate a type ID, so this means as many times I reload this page or whatever, the type ID will always be the same as long as that name never changes. So we're going to add to the prototype of that object. So that means every time we make an instance of it, it automatically has that component type ID. So there's something that doesn't have to be reinitialized every time you create it with the new function. And the same thing, we'll create a prototype for entity. So this we can save a pointer to an entity that the component is a part of. Like remember, the entity is just a collection of components. So when we modify the prototype and generate an ID number for it, we just add it to our components list, and we use a map object that's new for ES6. We use the name as the key, and then we create a dynamic object with the actual object itself, the reference to that specific object, not an instance, that reference to it, and then the type ID, and that's it. And that's all the code you need to just register a component. It's not a lot, but it works really well. And I love it that the functions and classes have a name property, so you don't have to like fill in an extra column like this is the name of the object. I can actually pull the name of the object dynamically, so that makes the code so much easier. So I just pass it in, and we're good to go. So if this function I pass in a string, I go find that object. If the object exists, I just say new c.object. Remember right here, this holds the reference to it. So I'm just creating a new object. If not, return null. And if I pass in a number, the same thing. I just search and find an object with that type ID that's on the component list. And if I do, same thing. I just make an instance of it. And that component is a function, and I just added these things on top of it. Just a list, which is the map, and 2 extra functions, one that checks to see if the component exists, and one to really just to kind of delete the reference to the entity, just to help JavaScript's garbage collector. I'm trying to be memory oriented, even though, I wish I had more control. I wish I had like C++ type of control in JavaScript, but I don't. I would like to have types. So with components all done, then we have entities. And in entities, and a lot of, they say an entity, all it is just an ID number. And a lot of things you read and some videos that people are talking about it. And right now I'm just using a random number for an ID number. And normally, like a C++, you would just create like an array, and that ID number would be the key, and then you have like an array of list of components, and that would be all. That would basically be your entity. Like you wouldn't have to, it wasn't an object or anything. But for my system, my interpretation of it, I want to have some functionality. So this is where I'm going to store my components. Now I want all my entities to have a name, and I want to be able to turn on and off my entity. So that's why I have it built this way. So I pass in name, and I pass in component list, and I call a function that's part of this class that adds by array. We'll see that in a second. And one of the first component things in entity, we want to be able to add a component. So we pass in a component instance, and it checks to see if it is a component. If it's not, it knows it's not an instance of it. And it just applies, it saves the reference to the component's entity object. Remember, up here. We add it to the prototype, so it's null. So we know there's a value that's always going to be there. And then we build a property name for the com object using the constructor's name, the component's name, and so this way you can reference it really easy in code. In some other frameworks I've seen, I was looking at, they just add an array and you have to go looking for the component. But since this is JavaScript and I want to make it easier for me to code, this is kind of a change I'm doing for myself. You'll see that when I want to access a component, all I have to do, I don't know if I have an example up here. Now I'll show you somewhere else. But it just basically, it's just entity.com.component1. So I can just access it in code very easily. Even though I have to write all these dot things, it's kind of annoying. But it's better than running a function like get component transform, save it into a variable, then modify. It to me more work. I don't want to call a function if I don't have to. So that's why I'm building it this way. Then we have a function called add by name. This way you pass in just the name of the component, and it calls the component main component object with the name. And remember, if I pass in a name, it just goes look for it and gives you an instance of it. Once I have an instance of it, I add it to com. Add by array, all it is an array of names, and it does the exact same thing. Finds the component, adds it. And remove com, and you have dispose. And that's all we have for our entity framework. And if we go to our main page, oh boy, I didn't even load in the next file yet. Oh, that's awesome. I'm trying to record a bunch of videos in one night, so we'll see how well this works. So here we are. I'm basically saying registering component one, component type, and array have that information. Maybe I can do this, make this a lot easier. So here's component 1, here's component 2, and here's component 3. So I'm registering 3. And why? 1 and 2? Oh, because 2 is, okay. So you see, these are automatically registered. And I show you there's like different ways I actually can initialize it. So I have like the class name. Then at the end, for fun, I just say, here's the component. I'm calling that component that exists here and passing in the reference. Another way is I can say here's components, and then I pass it in as a parameter. So this way, com3 doesn't exist globally at all. So that's one way if you want to create a component but that object name is not available to you globally. It kind of makes it this private component that can't be accessed unless you access it through the component's function. So that's another way you can go about it. Like you can have more control over it. Then I have a function that calls com2, and up here I can just say component, pass in the function reference, and if I refresh, now com2 exists. And like I said, I can refresh as much as I want, and the ID numbers will always stay the same because they're hashed based on the name. So let's say if I want to make a component, I just pass in one of the ID numbers, 97. So that means I'm making an instance of component 1. There it is, component 1. I can pass in just the name, like I said, and that should make an instance of component 2. Nice and easy. And now let's make an entity. So make an entity. There you go. And if I look at the com list, there's nothing on a com list. So there's, like I said, I have various different ways you can add com. So I can say, well, I want to make an instance of component 2, and I want to add right into it. So if I click refresh, if I open it up, and there's com2. And see it, like I said, you can access it with entity.com.com2. Makes it easy to code. So yeah, I can just do this, com.com2. And that makes it super easy to reference it. Refresh. There you go. See? com2. As opposed to other systems where you have to say get com2. I don't like that. So, in case you're wondering why I built it, where I'm building dynamic properties in an object. I can add by name. So this way I don't have to create an instance. It automatically creates the instance for me. And I don't want that. Go away. Refresh. Now the entity should have com1 and com2. And if I want, I can get rid of these. And I can just load them up this way as well. Just add to it. Refresh. And it should be still 1 and 2. And if I really want, on top of that, if I don't want to make it even shorter way, I can just do it this way as well. Entity, here's a name for the entity, and I just pass in a list of names. And there you go. Now it has a component 1 and 3. And that's it. Very easy to build components. And the whole idea of building these entities, I can say, well, this component, let's say if I'm building like a user entity, a user component. So I can say, I want this character to have health, and I want, and on top of it, you can add like items like dynamically. Like here's a nice good example. So let's say you have a character and he got stabbed with a poison bullet or something. I don't know. You can say add by name poison, right? So this way now that entity now has a poison component attached to it. So once you have a system, you can have a system that says, okay, show me where all the poisons are. And if it finds a poison, you say, okay, well, I'm going to have to render like an animation around the character so to show that he's poisoned. And for every frame or for every second, he's going to lose a piece of his life. And then you can say, well, after like 10 seconds, remove it. So then you have like e dot, at some point down the line, remove com poison. And then the next frame, you no longer, the animation stops, and then you stop losing life. So it becomes very easy to kind of just build pieces. Like I said, you start turning your components into Lego pieces. Like I said, you can start off by saying, hey, you got poison, let me just add that component to it. The component does its job for a while, and eventually maybe it deletes itself. and then your character's back to normal, and then becomes these like I said, these little Lego blocks that can just be built in, so you don't have to like build this object and it has all these if statements or anything else. It becomes a very flexible system. Right now you can't see it yet because we still have a very small. We don't have anything yet, but once I start adding more things, by like third or fourth video, you're going to start seeing the system actually work how it is. So I'll end it at like that, and then the next video we're going to start build the system even further. So yeah, hope you like it. Please like and subscribe, and see you guys at the next video.